if ft has a Fourier transform f of omega, what is the Fourier transform f alpha t? Can somebody tell me? If you stretch the t-axis, how does the Fourier transform change? Very simple. Right? By change a variable, this is nothing but this, you know. Keep this in mind when we are using this. Okay, let us say ft is a band limited function. What does that mean? The f omega strictly limited to minus 2 pi b2 plus 2 pi b in terms of omega. Such functions are called band limited functions, strictly band limited function. And then ft is equal to right, by definition, because the integral is only from minus 2 pi b to rest of it is 0. Now, e to the power of j omega t is also in the integrand, and e to the power of j omega t also will be affected by minus 2 pi v2 plus 2 pi b. So, now let us look at e to the power of j omega t as some function gt, right, limited to g omega this function also limited to this end. Now, so e to the power of j omega t is limited to this. Now, I can expand this in terms of Fourier series in omega, right. So, e to the power of j omega t is equal to Would you agree or not? Remember your Fourier series. And what is A n equal to? What is this equal to? Something I am doing wrong. I am now expanding this as a function of omega, right? So omega, let me write down here before I make mistakes. If you have a periodic function, right, where omega naught is twice pi by t. In Fourier series, where a n is equal to this is Fourier series. Now let us do this translated to the variable. Now I am talking about omega as the variable. So this becomes g omega is equal to sigma a n e to the power of j n omega twice pi by 4 pi b. Put omega wherever t is there. So width of this is 4 pi b, width of this is t. Omega naught is twice pi by t, twice pi by 4 pi b. Just 1 to 1. And what is a n equal to? Look at that. Right? And this is equal to